Okay. So all this time we have taken a grammar, later we have developed the automata. Now it is the reverse process. They have given the diagram. Now we have to tell whether the given diagram is applicable for the which type of grammars. So if you remember, we have taken AB power n, where n is greater than or equal to 0, or n is greater than 0, or 0, 1. You can take of grammar of that type. So what is expected here is in the first one. So we are moving from Q0 to Q1, Q2, Q3 and back to Q0, and Q0 obviously being a both initial state as well as a final state. So they have not mentioned the initial state. They would have given arrow mark. That is a problem here. The arrow mark is required for the Q0, and Q0 name itself is a initial state, of course. Okay. Now, when I give 0 at Q0, I'm going to Q1. At Q1, I can come back to Q0. So initially, it is a combination of 0 and 1. So to start with, how to write the grammar now? Initial state Q0 to Q1, I will go with 0, and that is not end. I need to come back to the final state. So upon 1, I will come back. So 0, 1 is a group. That is one possibility. Next, suppose I am at Q1. Upon 1, I will go to Q2. Then again after 1, I'll come back to Q1. After 1, I'll come back to Q0. So there is a sequence of ones after 0, 1. So minimum 0 is required. After that, there can be sequence of ones. That is another way of looking at the grammar. So first one is 0, 1. Next, sequence of ones after single 0. That is a leading 0. Okay, next option. After 0, I may get 1. I may get another 0. I may get another 0. I may get sequence of ones. Then that is also possible. Or 0, 1, 0, 1. Like that combination is also fine. So this is the 4 options are available for us for the grammar to be used here. So first option is 0, 1. Second option is 0 followed by 3 ones or 1 ones. That means odd number of ones. So 1 can be a single one, or 1 can be odd number of ones. Similarly, we have after 0, odd number of 1 followed by 0, even number of zeros, that is 2 zeros. So like that means 0, 1, 0 is oscillating with the different numbers. So probably we need to write it as a 0, 1, 0, 1. So 0, 1, 0, 1, 0, 1, 0, 1 is always a combination. But how long? If I take 0, 1, 0, 1 is one group. If I take again 0, it is not going to match. So 0, 1, 0, 1 is fixed there, meaning that I can have 0, 1, 0, 1 combination, or simple 0, 1 combination, or 0 odd number of ones, or followed by 0 odd number of ones followed by even number of zeros, and stuff like that. So there are 4 varieties here which we can use here. So we can club all these 4 now. Maybe let us say a 0 power n and 1 power n. If I write, is it going to match? If I write 0 power n or 1 power n, that is, even if nothing is there, it is going to be a final state. So I can take n is greater than or equal to 0. Is it going to be work? Let us see now. If I take n is equal to 2, what is n is equal to 2? 0, 1, 0, 1. So is that going to be valid? Yes. 0, 1, 0, 1 is a valid one. So up to that it is fine. If I take n is equal to 1 only, that is 0, 1, that is also fine. If I take n is equal to 3, 0, n is equal to 3 now, 0, 1, 0, 1, 0, 1. If that is the case, how it is going to be? 0, 1, 0, 1 is fine. Another 0, 1 is also fine. So I can write this grammar as a 0, 1 power n, where n is greater than or equal to 0. So that is the combination with which I can say this particular automata can be feasible. So there are so many options are there. In that I am taking the best option, like you do in a scope resolution operator, or maybe in a function overloading or operator overloading in C++. We have 3 steps process, no? Like that we have process here. There are 4 options available but I am taking only one best possible option, which is 0, 1 power n, where n is greater than or equal to 0. Is that clear?
Yes, sir.
Okay. Similarly, the second one, that is going to talk about our identifier. So how identifiers have been considered. So in the first case, it takes alphabets, goes to the state 2 and goes to the final state as well. Upon that, it may take some more data and goes to the final. So initially it should be character, followed by group of characters or digits, and followed by, I don't know what was there at the end. So I'm not visible, it's not visible. So based on that character also, we can go to the final state. Second option, it can be, not able to see here. 1 second. Yeah, second can be digits and followed by digits. So combination of digits also a valid. Next we have a comma, plus, hyphen, multiplication and stuff. That is also possible. Then we have a colon, equal. There are 4 varieties here written again. So one for the identifier, one for the number, one for the arithmetic expression, one for the assignment statement. So this single diagram what we have here is not only for one particular, what is a grammar, 4 different grammars can be taken here. That's why we have a branching here. If you look at the first diagram, it is only single grammar, whereas in the second diagram there are 4 multiple grammars. The 1 to 2, 2 to 3 corresponds to an identifier, 1 to 4 corresponds to a number, 1 to 5 corresponds to a arithmetic expression, 1 to 6, 6 to 7 corresponds to an assignment statement. So 4 different grammars have been put into the single automata theory, a single automata diagram. So we have to write in that direction. So we will be getting 4 grammar rules for the second one, whereas 1 grammar rule for the first one. So this is how we should, but while writing exam, you cannot simply write one sentence, you should give the reason. So we have 4 different varieties. From those different varieties, this is the best suitable. So a trial and error method we have to showcase. Simply for 0, 1 power n, people may not be able to give you full mark. So you have to deduce how you got 0, 1 power n. So by having the each possible outcome that we are going to get from this diagram. So that is how it should be done. So is it clear, or if you have any doubts, please let me know. Is that over? Any doubts?
Like grammar means we have to write BNF grammar or simply like 0, 1 power n like that we have to write.
Yes. That is outcome.
That is the doubt for me.
That is outcome. But to get that process, you have to give. Second diagram, yes, you may not be able to write 0, 1 power n like that, because first one is a.
Yes, sir.
You can write a statement also. A grammar need not be 0, 1 power n always. Wherever possible, you can write. But here, what is that? A statement will be there. What is the statement? An identifier should begin with a capital letter, followed by sequence of capital letters or digits ending with so and so. This is how we can identify as an identifier. So grammar, sometimes you can represent as a formula like 0, 1 power n, or you can write a statement also. Not a problem. So second diagram, you will be writing more statements than formula. That's how the grammar is. So this is what the grammar is. You have written no grammar, read, statement, like that. So sometimes when you can represent in this form, you can represent, or if you can represent in the sentence form also. Not a problem. Anything else?
So last question.
Last question, correct. So there are two inputs given. One is read value, second is read n1 comma n2. Simply by looking at it, we can say the first one is a valid one, second one is also a valid one. Probably. Okay, yes. Why? Because the first one is read ID list. What is ID list? ID list can be an ID followed by another ID. If you remember, we have taken earlier, there was a R symbol here. If you take our example, what was discussed in the class, there was a R symbol. Anybody observe this? ID list was
Yes, sir.
R ID list comma ID. That was the grammar we had. I have removed that just to see how you will understand this now. So what I have listed here is I have written ID comma ID, meaning that a read statement is a one which should have at least minimum two values. So first one is not going to be valid as per this grammar. As per the grammar, what is listed here, read value is invalid. Hello? As per the grammar given here, first one, read value is invalid because it takes only one value. But what is the grammar here? Grammar takes ID, comma ID. So minimum two values are required here. So thereby read n1 comma n2 is a valid one while read value is an invalid one. So what is the confusion here? This ID R symbol is missing here. In all your discussion, we have put R symbol, but here R symbol is removed just to check out how you understand. Okay, so that was the confusion probably. So this is how it should be now. So now even in examination, go through the grammar that is given, accordingly try to check what is solution. Okay, so that's what we have to do. So attention should be given to the actual grammar here. There is R symbol, meaning is different. If there is no R symbol, meaning is different. So that's what we have to say. Now they have to write a recursive descent parse. So for this, it is a failure. If you write a recursive descent parsing, it becomes a failure because it cannot go to the non-terminal symbol read because it is failing in the first iteration itself. Whereas here, you can always go back to the main symbol that shows that it is a recursive descent parsing. So that's what we have to see. Is it clear?
Yes, sir.
It's a top-down approach, recursive descent. Fine. If that is done, let us go to the question paper. Hope the question paper is visible now. This we have done. And I told you to check the program 3B. Hope you have done. How to generate the object code. It's a fairly simple program. Okay. If you don't have any doubts up to 3B, I will move to question number 4. Let me know if you have any doubts up to this point.
No doubt, sir.
Okay. Question number 4 now. So explain the working of a load and go assembler. So if you remember, we have used this name for one pass assembler. So we have taken two examples for design of assembler. One is one pass assembler, other one is a multi-pass assembler. So one pass assembler was also known as load and go assembler because it will not be able to store the program in the memory. It is mainly for the temporary trial and error method or maybe development and training type of requirement. If that is the case, the one pass assembler is called as a load and go assembler. So they have given a new name for you to just confuse you or twist you. So you should not forget. So one load and go assembler is nothing but one pass assembler. You have to write that assembler only. Next, what is program relocation? Explain how program relocation is done. For extended format is solved using modification record. So very straightforward question. Again, it is asked last question paper also it was there. Now also it is being asked. Explain the relocation, how it is being done. Okay. So this is how the second module is. Coming to the third module, algorithm for an absolute loader. Given last exam, it was asked. So absolute loader is being asked multiple times. Give the format of relocation bits used by loader. So we know the relocation bit, that FEC, FFE, and those stuff we have used, and how this format is going to be used is what asked here. And explain the same relocation bit with some example. So you have to write the object code H, T, E, and all, and explain how this is being visualized with a small example. Okay. Next, illustrate the concept of a program linking performed by a loader with a block diagram. So we have a diagram where three diagrams, in fact, one diagram with a program linking, with another diagram with by taking program A, program B, program C. You have taken a common instruction like reference 4, if you remember, and we have used the same reference 4 as a NDA minus list A plus some program A something, and that same instruction has been used at multiple programs like program A, program B, program C, and everywhere we have shown that the address comes back to the same value. How it is being done? That is done through a concept called as a program linking. So that diagram we have to write and explain. We have discussed in detail. Probably we can cross check and utilize that. So coming to the problem 6 of module 3. Compare and explain linking loader linkage. Again, it was asked in the previous exam as well. So this is also very important. There it was asked for a dynamic linking. Here it is asked for a linking loader and linkage editor. The what's a comparison. Next we have a MS-DOS linker, which was given as assignment. So again, I'm repeating, assignments are not for the sake of writing assignments. They're very important from exam point of view as well. So we need to write them with a proper conviction. Next, coming to the module 4 with macroprocessor, the data structures used by macroprocessor with a block diagram. So which is a block diagram here? We have a block diagram for a definition table, argument table, and name table. That diagram we have to write and explain the three data structures what are being used in the macroprocessor. So again, wherever possible, illustrate with the example. That is very important. Okay. Next, example of for the concatenation of macro parameters, the ampersand, arrow mark, all those stuff we have seen in the concatenation that we can use. This same question was asked in the earlier question paper as well. Next alternative here is basic macro processing functions with suitable example. What is macro processing functions? That is nothing but a macro processor functionality, which is nothing but macro definition, macro call, and macro expansion. They are nothing but the three macro processor functions. Okay. Next, describe the salient features of ANSYS macro processor, which was again given as a assignment for you. So don't look at the marks and all, because this scheme is different. For you it is different marks, but what you have to see is the type of questions that are being asked. Okay. Next, module 5. Write the BNF grammar to the assignment statement of a C program for the expression sum is equal to A into B plus 50. So I think while taking class as well, we have taken this particular example. I told you to construct the BNF grammar for the simple statement like this. There is not a big statement that is given like in the syllabus, but it's a simple statement for which we have to write. So generate the parse tree for the expression using the grammar. So they have given the grammar, the expression. Now we have to write the grammar for it. How to write the grammar? If you remember Pascal, there are 4 sentences. Expression is equal to, assignment operator is equal to expression. Then expression can be a factor, can be maybe different types of values. All those stuff have been used, and like that we have to write here. We have a parenthesis, we have a multiplication operator, we have a plus operator, we have a number, we have a character. All those stuff are there. Then we have to figure out. So first we have to write the grammar, that is 2 to 3 statements which fall for this particular one. Next we have to write the parse tree based on that grammar. So probably you can try this now. Let us see, because during the discussion I don't know how many have followed it. Now it is right. So what we can do is write a grammar for sum is equal to A into parenthesis B plus 50 close parenthesis. How we have to write? We have to write in the similar lines. How the what to call the expression for Pascal has been taken. So it is nothing but assignment operator equal. We have expression. That expression can be considered as a factor or an expression or a term and stuff like that. So now that was a bigger expression. Now you need not write such a big one. What is given here is a only multiplication and plus, only character and number, only parenthesis. Keeping that in mind, probably we can resize that. So probably we can try this. We can get back to you maybe 5-10 minutes after this now. So try this, how to write the grammar. First write the grammar, then write the parse tree. So 4 marks for the grammar, 4 marks for the parse tree. So that is how we have to look at this now. So try doing this. I will connect with you maybe 5-10 minutes from now. If anybody is ready, you can present it. I will stop it right now. Anybody done? Is anybody done? Whoever is ready, you can project. You're trying or not? Fine.
Sir, shall I share the screen, Arjun?
Yeah, share.
Sir, can you see?
Not clear.
Sir, network problem too. So
Wait. Clarity is not. Okay, assignment statement id is equal to exp is equal to term plus expression. Okay, term is equal to factor, term plus factor. And where is multiplication here?
sir, it is multiplication, not plus, sir. Term into factor.
Okay. id or int or expression. Okay, so b plus 50. How do you match that? Factor plus factor. But where is the factor plus factor? See, b is a id. 50
Yes, sir.
is integer.
Yes, sir.
So id and integer are factor. Factor plus factor. There is no factor plus factor, no, for you.
Yeah, sir. So I think like there is a
Okay.
division, sir. You see.
Yeah, term can be factor. Okay. Factor plus factor. Expression. No, it is not fine. See, factor plus factor is not there. Factor into factor is there.
Yeah, sir. See, there is a like factor by term into factor. So when
Where
I
is the
took,
term into factor? That's what term into factor means. It can be
yeah, sir. There is a, yeah, sir. Yes.
uh, but there is a factor plus factor. B plus 50 is what? Factor plus factor.
Yeah, sir. Yeah, I took multiplication. So, sir. Okay, plus I missed, sir. Okay.
No. In the factor definition, it should be term plus factor.
Okay, sir.
Then expression can be term plus expression. But their term is
Yeah,
what?
sir.
Factor. The grammar is not correct.
Okay, sir.
See, division,
Expression.
you have brought division, it not required. No, why you have brought division and all? You're only confusing.
Okay, sir.
So that was there in the Pascal grammar, but they're not asking. They're very simple grammar they're asking. So how it should be? Assign is equal to id equal to exp. Perfect. Second, what is exp? Exp should be
Term plus exp.
two terms.
Term plus
Two terms. Yeah, whatever. Two terms. Term plus exp. So what
exp.
I suggest is instead of term plus exp, make it term into exp.
Okay, sir.
So what is exp now? Exp can be term into exp.
Exp.
Okay. So now,
Yes.
what is the term? Term can be a, or term can be a factor. Factor can be id.
Yes.
That part is taken care. Next, what is exp? Exp can be term multiplication exp or term. So
Yes.
exp you have to redefine. It can be term plus exp or term. Things. Otherwise, b plus 50 will be missing.
Yes, sir.
See, every non-terminal symbol will have a terminal symbol. On the other hand, every terminal symbol should go back and sit with the non-terminal symbol. That matching should be there. There should not be any heterogeneity here, or there should not be any non-synchronization. That may not be going good. So grammar will fail then.
Okay, sir. I'll try, sir.
Yes.
Sir, sir, shall I stay?
Please.
sir, can you see?
Not visible. Grammar. Assign ID exp term or okay, somebody is calling you. Yes, term is a factor. Term plus term into factor. I think okay. Factor is okay. Okay. Term plus exp. Exp. Parenthesis factor term exp can be term plus term. What is term plus term? Okay, that's fine. Yes, it's okay. Should be like this.
Okay, sir.
Yeah, and diagrams also you should write 4 diagrams like this, not 1 diagram. You have written no step-by-step diagrams.
Yes, sir.
Even in the exam, everybody should write these type of diagrams. Don't write one single diagram. Always show how the diagram is constructed, how the parse tree is constructed step by step. This is a good practice. Okay. Good. So hope all of you can follow this, and let me continue with that. Thank you, both of you. Okay. So in continuation, it's again mission dependent code optimization. Even in the last question paper, the same thing was asked, mission dependence. And second, they have given an automata theory, automata diagram. We have to check whether the given input is valid or not. We have done it already. It's very simple one. Next, the short note on P code compiler, which is a pseudocode compiler or a Java type compiler. Next, we have ACK compiler. Hope all could write. I think ACK was given as an assignment. Hope you could find the solution for that. So with this, the question paper for this particular January 29 for your senior batch. That means different scheme, but syllabus was same. Okay, but questions will be 99% will be same as like this. So this was the one question paper. So this is what we could see. Let us take one more question paper of the same pattern. In January 2000, July. So this is another question paper. Are you able to see the new question paper? Is this visible?
No, sir.
One second. Okay, now?
Yes, sir.
Yes. So this question paper, again, pretty same questions, system software versus application software, and the SICXE architecture, which we have been familiar and we have been talking about this from the beginning. Next, fundamental functions of an assembler. We discussed again in the previous question paper, where we have to write about both pass 1 as well as pass 2. Explain any 4 assembler directives. Again, that is important. Data structures used in assembler algorithm, that is optab and symbol table. Here it is asked for 6 marks. If you simply write 2 tables is not enough. You should also explain how, with a small diagram, how symbol table, a small example, how symbol table is going to be written. So take 2 lines. Start copy 2000, LDA 2003. Then when you see some symbol, let us say copy 2006, how the data is going to be entered into the symbol table. So like that, you have to channelize your answer. Simply if you write what is there in the notes, 2 tables, it may not serve, because the question is completely on data structures. For 6 marks, we should write some better solution for this. So that's what we advise you to write solution as per the question, not what is available in the notes alone, because we have to customize that with more examples. So try to write more examples here. Next, 2-pass assembler with a 1-pass assembler. They're asking comparison. So we know the plus and minus of 1-pass assembler, and at the same time the plus and minus of a 2-pass assembler. Maybe it is a innovative for you because you are not thought of. You can work out on this. Just at least 4 to 5 points you can list out between these two, 1-pass assembler and 2-pass assembler. So advantages of 1-pass assembler is is only one pass, takes less time. So compared to two pass. Similarly, two pass assembler consumes relatively more time compared to one pass. In one pass, we need more data structures because in single pass we are doing so much. Whereas in the case of a two pass, whatever we know, the two data structures are sufficient. To handling forward references is a challenge in one pass, where it is easy in the two pass. We require additional data structure called linked list in one pass assembler to handle this. Otherwise, it is not required in the two pass assembler. So like that, we have to differentiate between these two. Now, how forward references are handled? Oh, that's what we know. Again, how one pass assembler design is there. Same thing we have to write with the diagram and data structures. Okay. Next, we have a MASM assembler, which we know as an example of a real time. Next, literal operand and immediate operand, which is a very important question. How does the assembler handle literal operand, that equal operator and stuff like that? Explain the concept of a program relocation. It is there in every question paper almost. So it's very important. That shows the importance of program relocation. Then briefly explain the bootstrap loader with algorithm, the two parts of the algorithm which is there for bootstrap we have to write, and dynamic linking with suitable diagrams. So what is the dynamic linking? Those 5 diagrams what we have, very important. So those diagrams we have to write for the dynamic link. Next, linking loader and linkage editor, the diagram and differentiation. In the previous exam also it was asked. Then MS-DOS linker, which is again a real-time example. Algorithm for one pass macroprocessor. See, we have not discussed one pass macroprocessor in detail, but whatever the macroprocessor algorithm we have, we can write that. That also will be helpful to some extent. So don't think too much about macroprocessor here, because that is only for a small period or small amount of software. So whatever the algorithm we know, we can write this for microprocessor to understand to start with. So you can go ahead with the algorithm what you have taken, which is having some 5 small sub programs. Then concatenation of macro parameters, again it is being repeatedly asked, and keyword macro parameters, it is also asked again. Then what do you mean by a macro? That is a assembler directive. So explain macro definition and expansion, that is the functionality of macros. Again, the same question was asked differently in the previous question paper, but both are same solution. What is the macro definition? Macro call and macro expansion. Advantages and disadvantages of general purpose macroprocessors. We have taken this as one of the design concept of a macroprocessor. If you take general purpose macroprocessor, how it is going to be useful, how it is not. I think we have listed the same advantages, disadvantages also. Write about the general purpose macroprocessors in detail. Next, finite automata. Directly they have asked you to take any example. You have a liberty to take example, but don't satisfy with one example because it's for 10 marks. Take some 2-3 different examples so that it will be easy for the examiner to award the marks. Okay, and not only example, write the diagram, take valid, invalid, and ascertain. So if you take 2 diagrams, 5 each inputs for these 2 diagrams, it becomes 10. So they can give 1 mark for you. That's how you have to attract the examiner towards your solution. So 1 diagram, 5 inputs, valid, invalid, like that. So 2 diagrams, 10, you can get 10 marks. Describe the process of compiler. It is nothing but a ACK. So they can ask as a ACK, or they can ask like this as a compiler. Both are same. So because ACK stands for yet another compiler. So you should not get confused. So this is the alternative name for the ACK, compiler. Next, explain the mission dependent code again, mission dependent code optimization is asked. It is asked in every exam almost, like a program relocation. Then what is a parse tree? Give an example. So you can, when parse tree example is given, you have a full freedom with you. You can write recursive descent parsing. We can write any type of either a top down or a bottom up. Both are fine. So you can take examples again and write a parse tree. It is a very straightforward question paper. Very simple though. Okay. So I don't think any doubts in this question paper because everything is straightforward. So probably we can conclude at this point, and next class onwards. So probably some of you can take some few and start discussing. So I gave voluntary, nobody came forward. So what to do now? You want me to give or?
Sir,
Sir,
Arjun, sir. Right, sir. Shall I share the screen?
Share.
Sir. Shades.
No, first grammar is important. Once grammar is ascertained, then diagram will follow.
Yeah, sir. Like
Yeah.
that one I wrote in other page.
Hmm?
This one, sir. Fourth diagram, last one, sir. I corrected. Here in place of plus, I written multiplication, and
Okay.
this is open and closing bracket, sir.
Parenthesis.
Yeah, sir. B plus 50.
Factor plus factor. Okay then, fine. But write grammar. Grammar is important.
Okay, sir. Thank you, sir.
Thank you. So how should we proceed from next class? You want me to repeat, or will some of you will come forward to discuss? How should we do?
Sir, can you do the revision of 4th and 5th module, sir?
4th and 5th module.
Yeah, sir.
What happened to that?
No, sir, I felt little difficult. I don't know about others. I felt difficult, sir.
How about others?
Yes, sir. Same here.
So first 2, 3 are not important, huh? No confusion.
I
Important, sir, but we can do.
Okay, fine. If revision is required, we'll go with the revision then.
Sir, object code, sir. How to calculate the object code once you revise that.
Object code I will not discuss, because while discussing itself I asked, none of you came forward. So I told already at that time, this is the only batch which is not bothered to ask me about object code. So object code I will not discuss, because that time is given to you already if people have not used it. I can discuss module 4 and 5. Because I gave 2 days while discussing module 2nd, and I reminded you, come back. I definitely know object code is not easy. None of you bothered. That really irritated me. So I don't want to discuss that again. So fine, we'll start with module 4 from next class. But I will not be talking like this. I will ask you questions, you have to answer me. If you're not able to answer, then probably I will help you. That is revision. If I again teach, that is not revision. So it is responsibility for all of you to read module 4 for next 2-3 hours. If you ask me to repeat line by line, I will not be. I will say microprocessor, tell definition of some. You should tell. I don't mind even if you read from the notes, but you should open up. Don't expect me to talk. So next class, which I will be doing revision, I will not be talking much. I expect each of you to talk first. If you're still not able to answer, you have doubts, then I will help you. Is that okay?
Yes, sir.
Yes.
Yes,
If you
sir.
don't talk, I will abruptly close the class. I will say goodbye. So revision is not from my end, revision is from your end. So I want more interaction from you than by me or from me. If this is the deal, we can go with the revision. Otherwise, revision has no meaning. Fine. So with this, we'll wind up. Tomorrow I will take second hour, 9:30, where we'll discuss module 4. So before that, come prepared with the module 4 discussion or notes, what is there with you. Thank you.